Hello everyone, my name is Vera and I'll be teaching IB Chemistry for the 2025 Winter Intensive course. I'm really excited to work with you all during this intensive session. Over the 3 weeks, our goal is to strengthen your understanding of key chemistry concepts and help you feel confident for the upcoming school term or for Year 2 students for your final exam in May. Let's start with the Year 1 students during this course. Our focus will be building a strong foundation in chemistry. So in week 1, we'll review the basic concepts, starting with chapter 2, atomic structure, chapter 4, models of bonding and structure, and chapter 5, periodicity. And in week 2, we'll move on to chapter 3, quantitative chemistry, focusing especially on calculations, and then cover chapter 6, organic chemistry, where you'll learn about functional groups and reaction types. Finally, in week 3, we'll focus on chapter 7, energetics, studying how energy changes occur in chemical reactions. Now, for Year 2 students, our main goal will be to master the deeper concepts and practice past paper questions to prepare for the final exam in May. In week 1, we'll start with chapter 3, quantitative chemistry, chapter 6, organic chemistry, and chapter 7, energetics, focusing on problem solving and data analysis. In week 2, we'll cover chapter 8, kinetics, chapter 9, equilibrium, and chapter 10, acids and bases, emphasizing conceptual understanding and application to exam-style questions. And the final week, we'll finish with chapter 11, redox reactions, and chapter 12, electron sharing reactions, integrating these topics with practical examples and review exercises. So by the end of this course, you'll not only have a clearer understanding of key chemistry concepts, but also be more confident applying these concepts to real IB style questions. So let's look at a couple past paper questions together to show you what my class will be like. The first one is question number 1 from the 2022 November paper. So how many oxygen atoms are present in 0.05 mole of the given formula? And we're also given Avogadro's number right here, which is 6.02 times 10 to the power of 23. First, we need to figure out how many oxygen atoms there are in one formula unit of this compound. So we can divide the formula into 2 parts. So in barium hydroxide, we have 2 oxygen atoms present, right? And that's 1 each from each of the hydroxide group. And then the second part, which is 8 water molecules, there are 8 water molecules, and each water molecule contains 1 oxygen atom, so that adds 8 more oxygens. So in total, we have 10 oxygen atoms in each formula unit. But then in the question, we know that there's only 0.05 mole of the given chemical. So the number of formula units would be 0.0500 mole times Avogadro's number, right? And that gives us 3.01 times 10 to 22 formula units. And each formula unit has 10 oxygen atoms, right? So it would be this number times 10. So this number is basically how many formula units we have. And then this is for 10 oxygen atoms in each formula unit. So gives us 3.01 times 10 to 23 oxygen atoms in total. So the answer will be A. Let's move on to the next question. This one's from the 2022 May paper. We have 0.02 mole of zinc, reacting with 10 cubic centimeters of 0.1 mole per cubic decimeter hydrochloric acid. And the equation is given. It seems like the equation is balanced. And we're asked how many moles of hydrogen are produced. So what we are looking for is the amount of hydrogen gas produced. Right, so let's start by finding how many moles of hydrochloric acid we actually have. Right, so this number is basically number of zinc, right? And then this is volume of hydrochloric acid given. And this number is the concentration of hydrochloric acid, right? And what we gotta do first is basically converting the unit of the volume. So the volume is 10 cubic centimeters, which we convert to cubic decimeter. We need to do the calculation of dividing by 1000. And that gives us 0.0100 cubic decimeters. That's the volume of hydrochloric acid given. And we need to use the formula N equals C times V. So number of moles would be concentration times volume. So NaCl would be the concentration, which is given in the question, 1.0 mole per cubic decimeter, times volume, which we just got in cubic decimeters. And then the unit of per cubic decimeter and cubic decimeter cancel out. And this leaves 0.0100 moles of hydrochloric acid. All right, and from the balanced equation, this is the balanced equation, we can see that 2 moles of hydrochloric acid react with 1 mole of zinc. So the mole ratio of zinc to hydrochloric acid will be 1 to 2. So if we need 2 moles of hydrochloric acid for every 1 mole of zinc, but we only have 0.01 mole of hydrochloric acid available, right? So the number for here is basically 0.01 mole for hydrochloric acid. And that means hydrochloric acid is the limiting reagent. So this is the limiting reagent we got. And now from the ratio of 2 to 1, so the molar ratio of hydrochloric acid and the hydrogen gas would be 2 to 1. And the number of hydrochloric acid was 0.01 mole. So number of hydrogen gas would be 0.0100 mole divided by 2. So basically this number divided by 2. And that gives us 0.0050 mole of H2, which is answer option A. So that's it for today's video. I'm looking forward to seeing your progress and helping you succeed in IB chemistry this winter. Bye.